I come from the University of Verona. I'm a biotechnologist in a department of biotechnology. When NGS started, I decided to switch from biology to become a technologist and to test all the technology and try to understand them and to see when to use one, when to use the other. We like to understand what we are doing, and every single step, when possible. We still like to interact with companies and understand the products and to test them in order to then tell my colleagues what I think about a certain technology. If you are a, let's say, medical geneticist, you see the patient and you have to trust the data that you are analyzing. A guy called me and told me, we have this baby, we believe he has a mutation, we are sure he has a mutation in a certain gene. We made exome sequencing and we didn't find any mutation in the gene. It's not that every kit is covering every gene in the same way, and so it may be that region was not properly covered, and actually that was the case. So I think that in this case, technology is helping biology in order to choose the right platform and to understand if the data that you get is appropriate in the sense that you want to analyze exactly the gene that you want to analyze. This is part of my mission. When Illumina proposed me to test the new kit, of course I said yes. I'm very happy to give my evaluation to the company and also to give my evaluation of the product to my colleagues. And that is so important for my small community. Interacting with the companies means, at this level, interacting with scientists. And in these years, I've learned a lot interacting with scientists from companies. So I'm giving and I'm receiving. And so this is good for the company, for my society, but also for my group. We are learning a lot. The uniformity, the number of variants called, it was good. What I really appreciated, it has been that by telling you what I didn't like, and it's difficult for such a small group to talk to such a big company and say, I don't like this for this reason. But it has been fantastic to see that the big company listened and modified the protocol and then came back with a modified protocol, proposing me to test it again and to see if I was satisfied with the modification. I like it. I have to say that I like the protocol because it's very fast. So it's a fantastic protocol. You can also reduce hybridization time very much. My group is very much satisfied by playing with this kit because it's simple, very much reproducible, that is very important, and also quick. Uniformity increased dramatically. The fold 80, that is a parameter that we use, is now down to 1.5. That is very, very good. Also the uniformity of coverage and the area that is covered with at least one read is 1 point in percentage higher than before. So it's very good. The main impact I see is in the analysis of copy number variance. You will see this difference as a copy number variation when you will analyze all the sample together, but actually these are not copy number in the patient, these are simply artifacts of the technology. So with exome sequencing, always there is this variability in some or AT-rich or GC-rich regions that cause us to call a lot of false positive CNV. Having a reliable kit that is reproducible in terms of uniformity of capture allowed us to reduce the false positive for this kind of variants. Not to limit the evaluation of the quality of the exome to the coverage, the cost of the analysis, and the simplicity of the kit, but look at the performance and the uniformity of coverage. The quality of the mapping, that is depending on the fragment size. So the ideal situation is to have a very narrow curve of fragment distribution. This is so important because if that is very open, the curve, you will have a lot of very short fragments with low mappability. So you may have your candidate gene with a very high coverage, but low quality of mapping, so you have to understand which are the parameters for testing your exome kit.